Okay, welcome back to the channel, folks. Today we're going to talk about solar panels. As you can see behind me, we're here at one of our projects. Actually, this is my roof. I've put these up a few years ago, and I just wanted to talk to you about some helpful saving tips to get some good rated solar production. Now, you don't need to buy the most expensive panels on the market, and you shouldn't buy the cheapest. However, use discretion when you go to purchase. So behind me, I have a bank of panels that are 48 panels on this roof. So what we've done is line them all up in a series parallel configuration. Now, you can see as the panels that we've done, we've lined them all up here on the roof, and they're in groups. Now, these are 100-watt panels. They're a monocrystalline style panel. So I've talked about it before, but basically there are three types of panels. There's a monocrystalline, there's a polycrystalline, and there's a Morpheus. Those are the three major types. Now, out of those three major types, obviously monocrystalline is the most efficient. They're upwards of 20%. The Morpheus are becoming a thing of the past as they're not around much anymore. So you still have your polycrystalline, which are less than $1 a watt, and then of course your monocrystalline like behind me. So the difference is the monocrystalline are like a dark blue, almost a black color, as the polycrystalline are more of a lighter or medium to blue. The efficiency is a little bit less, and they're a little bit less money. So the first saving tip is that you should be looking for a monocrystalline panel. Now, these come in solid panels, they come in flexible panels, they come in a variety of different ranges of sizes and assortments. But what we've done here is we have taken 12-volt 100-amp panels, and we have wired them in series to get 48 volts, so 4 in a series circuit. And then once we've done that, we've done them in parallel and grouped them up to add our amperages up to get to our desired level. Now, as far as the wiring goes, you don't need to spend a lot of money on the wiring, so you don't really need to get into MC4 connectors. MC4 connectors can limit you. I know they're plug and play, but they can limit you to what you're doing in your wiring configurations, and they can also add quite a bit of cost to your wiring project or your solar project. So I'll get down off this roof, and then I'll show you what we actually use for wiring. Alright, so I don't actually have a piece of the SOW flexible cord cable to show you for the solar panels. However, what I mean is you can simply buy it at the hardware store. It's extension cord. So it comes with two conductors in it. It's flexible, it's weatherproof, it's ready for outdoors, and you can use it to hook up the panels. We use it for all of our panels. Just make sure that you look for a panel when you're making that purchase to ask for strain relief connectors, or look for strain relief connectors on the back of the panel so you can hook them up negative and positive. So that's it for that, but why I wanted to get you out here was to show you this solar panel system behind me. So everything that is on those panels come back to what's behind me. Now, you can see there's a variety of equipment here. Basically, it comes back into a number of disconnects, and then goes into some inverters, and goes back into the house. So basically what happens is the power comes into the inverters, comes into the disconnects, goes from the disconnects into the charge controllers. From the charge controllers it goes into the batteries, and then from the batteries it goes back up and into the inverters. Now, you can see behind me that we have a couple of controllers here and a couple of disconnects. So these disconnects are just basically when the panels come in from the roof, they come into here. This is an emergency disconnect, just so I have to shut it off in case I need to pull it off in case of an emergency. Now, you can get these in Eaton, you can get them in Square D, and you'll be very pleased to know that most of them, and especially the Square D, are rated for 48 volts DC, so you can actually hook up your solar to them. So remember, like I said on the roof, that the panels are wired in series, 12, 24, 36, 48, to give me 48 volts. After that 48 volts comes in, it then goes in through these disconnects and goes to the charge controllers behind me. Now, if I had to recommend anywhere to spend your money, it would be on your charge controllers. Here I've got a TriStar and I've got an Outback. The difference between the two is this is just pulse width modulation, or PWM. It's a cheaper charge controller. And this is an MPPT charge controller, maximum power point tracking. And for a number of years I didn't really know the difference, but basically this just takes the charge and converts it to store into the battery safely, and when it reaches its desired set point, 48 volts, it will shut off. This actually, what it does is it's great. It changes the amperage to meet the voltage. So this one here, actually a full charge on 48 volt system is 56 volts. So the low side, it can go down as low as 46, and the high side is 56. So if you take that, that's actually a 14 volt charge in each individual 12 volt battery, which is pretty much the max on these gel type or absorbed glass matte batteries. So what that does is, if you have, how can I describe this? If you have 48 volts at 100 amps, what it will do is it will cut the charge out, the 100 amp charge, at 56 volts. This one, however, will convert the amperage, which is really cool. So if you're at 48 volts, it will actually up your amperage coming in from your panels to say 120 amps or more. As it comes down and reaches the 56 volts, then it will slowly cut it out. So what you're doing is you're actually getting the peak out of your solar panel, because the solar panel, remember, isn't rated for it's rated for 12 volts, but it actually puts out 17 volts. So these type of charge controller utilize that. So if I'd say anything, when you're trying to save your money, don't try to save it when it comes to a charge controller, because that's really important. So what I've actually done is hook them up in groups of 4, 1, 2, 3, 4, 12, 24, 36, 48, in series, and then I've taken those series groups and I've hooked them onto a set of bus bars to give me my 48 volts. Now there's 88 batteries altogether, so I mean, you do the math. They're 100 amp hour banks, and there's a lot of batteries, so I've got a lot of storage time. It's actually probably about 2 days storage time if the power goes out. And you're going to say, well, if the power goes out, well, this is how I have the system set up, so I'll take you through this. But first, I just want to say where I got my batteries cheaply. If you look for postings online, a lot of times you'll find local companies in your area that will be doing battery change outs for communications towers or anything like that, that they need batteries for a backup. And they change these batteries out every 2 or 3 years. So you may be able to get batteries for a relatively good cost that are only 2 years old, and then get, you know, an AGM battery, a top AGM battery is rated for 15 years. So I'll get years out of these batteries behind me. So that's a really important key tip to save money on your solar system that you're going to design. Check your local areas first. Now, after the batteries, what happens is they all come into the inverter. Now, if there's any place in this whole solar system that I would say not to cheap out, is on the inverter. And the reason I'm saying that is because there are a couple of different types of inverters. So I'll just show you these inverters here. They're made by MagnaSine, and they're a pure sine wave inverter, off-grid inverter. So they're 12240 volts, 60 hertz. That's what they put out. They're actually a split phase, and they weigh about 90 pounds, and they have transformers in them. They have a number of electronics and boards to help them work, but you can see there where I have the lugs that come out of the wall with the large cables for the 48 volts off the battery bank, and this is what it pulls off of. I have 2 of them because I have them actually hooked up parallel, which each one gives me 30 amps of 12240 volts back to the house. So I'm actually running 60 amps 12240 volts back to the house. Now there's a number of things that you need to understand about inverters, and this was just self-taught with experience over years. There are 2 types of inverters, a modified sine wave and a pure sine wave. The MagnaSine ones that I have behind me are pure sine wave. The modified sine wave ones are quite a bit cheaper. You can see them on all the internet sites, and they most likely come from China, and they come from here as well too. They will not run any type of heavy loads. They will not run motor loads. They will not run sensitive electronics. They will not run microwaves, anything like that. So you get what you pay for, and that's why they're cheaper, basically. I've had a lot of experience with modified sine wave inverters. A pure sine wave inverter is what makes a clean sine wave of energy. They actually have to have either circuit boards or transformers. Ones with transformers are even better, because then you know you're getting some bang for your buck, and it's actually converting that DC energy or the solar energy into something usable. They'll run motor loads, they'll run microwaves, they'll run electronics, they'll run anything you can, because it's clean energy just like you would get from the grid. So that's why I'm telling you to make sure, if there's any place you spend your money on your whole solar system, I know you're trying to save money, and I know this video is about cheap ways to do it, which it is, but make sure you spend money on those inverters. It is very important. Magnasign is a big company. They're in the US. They supply Canada and the US, and I've had nothing but good luck with them. They're not paying me to do this, so it's just simply, honestly, good luck. They're electrician friendly, they're user friendly, they're DIY friendly. They have plenty of videos and how-tos, and great warranties. And I've had these in for some of my customers for 10, 12 years now, and haven't had a problem at all. So this is working greatly. Now we've gone through the batteries, we've gone through the solar panels, we've gone through the disconnects, we've gone through the charge controllers, we've gone through the batteries, and we've gone through the inverters. So that inverter bumps it up to host power. Now, you're thinking, what's this fancy thing right here? Well, this is a little bit of additional control I went with. Now, you don't need to go with this yourself, but this is a control station made by Magnum Energy. And what it does, I have inside contactors. So you're like, wow, all the wires. Anyway, so inside I have a contactor, and that contactor is basically like an auto transfer switch. So from the grid, I would get 120, 240 volts, 60 amps, which allows the batteries to be charged if I need them to, which I don't use that option, but it does allow the batteries to be charged. From that, the other side of the contactor is the energy from the inverters that are produced. I have a photocell outside. So first of all, it doesn't work at night, because I don't want the solar coming on at night for obvious reasons, because there's no solar at night. And secondly, it checks every hour with this auto generator start if there is solar available. So if there is solar available, it flips over to the solar and uses that for the house first, which is so cool, because I don't have to do anything. It just kicks over to the house, and if it's a cloudy day, it stays on the grid. So I don't have to worry about the actual panels or doing anything myself or flipping them all off and on. It's totally automated. So that's one of the things that you can do. You don't need to do this for obvious reasons, because it's at a cost, but I decided to do that. But I mean, right here you can see that it's inverting. We're at 48.8 volts, and we're pulling 23 amps DC from the system right now. So I think some key factors that I want to talk about, and I want you guys to take away from this, is number one, do your research on your solar panels. You don't need to buy the most expensive. There's plenty of stuff available online, but you should go with the monocrystalline style solar panel. Secondly, I recommend going with 12-volt panels, because it gives you a variety of options. You can wire them in series, or you can wire them in parallel, and you can go 12, 24, 36, 48, whatever you want to do. You can even combine them together with the grid tie if you want a grid tie. Thirdly, watch where you're going to install them. You're going to want to install them on a metal roof or some sort of a structure, not an asphalt roof. Everybody does asphalt roofs, and of course then they realize they have to take them off to have the roof replaced. I'd say another thing is the wire that you connect them to go with. You can go with the MC4 connectors, but they do limit what you're doing with the system. So like I said, we choose to wire them in an approved wire. And actually I should mention that the SOW cable, since it's CSA approved, is approved by our inspection authority, as long as it's done up properly. When you're connecting your panels together, another important thing, if you're living in an area that gets snow, you should make sure that the wires are securely fastened to the back of the panels, so you don't get snow sliding down behind the panels and ripping the wires out, because I've had that happen before. So after all of that, you need to bring that back into some sort of a disconnect system, just in case of an emergency. Square D makes a really good cheap disconnect. Their 30 amp disconnect is rated for 48 volts DC, so you can use one of those. They're available online, relatively cheap. From there, you need to go to a charge controller. Now, like I said, there's a variety of different types of charge controllers. You should always add up the amperage of your panels of what they're going to put out, and you should always lean towards an MPPT charge controller on that side. From that charge controller, then you're going to go to your batteries, which you can find locally. I don't recommend buying batteries online because the shipping weight is ridiculous. So just do your hunting in your local area. And remember what I said about communications towers, because a lot of these communications towers use these batteries, and they replace them every few years. So you can get them relatively cheap. Your inverters, you should not cheap out on. Like I said, dimension behind you, you could just use an actual you should make sure you use a pure sine wave inverter, and there are a variety of those online, so check out those as well. And then finally, how you're going to take it off to go to your house. You should get either an approved auto transfer, or if you don't, just completely separate the electrical that you want to use for the solar. So if you have a building you want to power, have a separate panel for that. You don't need to intermix it with your house like I did, but I just got a little fancy, obviously, because I've been doing this for years. So you're probably going to notice some things in this video that people are going to say, well, it isn't up to snuff. Of course, we wouldn't do it this way if we were doing an install for a customer, because we'd have to get it inspected, but this wasn't inspected, so I was actually looking for cheaper ways to do things to still get the same result, which is what this video is all about. So I hope you liked the video. That's it for today. Don't forget to like and subscribe. Stay tuned for more videos on other topics, and that's it.